Welcome to the Chapter 8.4c lesson video. Today we're going to continue on with sine and cosine graphs. We're going to focus on the shifting part of sine and cosine graphs. We can do this along with changing the amplitude and period, but we're going to worry about that more during our live session, doing a combination of those things. Just for this video, we're going to focus on just the shifting aspect mostly and how that works. These are the same learning targets we had for earlier, recognizing the shape and recognizing how to stretch, shrink, translate, reflect these graphs. All right, quick recap of what we've done so far. We've talked about the sine and cosine graphs, how to label them. By default, we give them an amplitude of 1 and -1 and a period of 2 pi. And we can label all these different tick marks in between. The sine graph follows the shape that starts at the middle line, goes up to the amplitude height, back to the middle line, down the amplitude height, back to the middle line, filled in with a nice smooth curve. Now, one thing to recognize is that today we're going to move that middle line and this graph shape will move with it. The other graph was the cosine graph. We label everything the same. So 1, -1, pi over 2, pi, 3 pi over 2, and 2 pi. And it's a little bit different. It starts above the middle line, the amplitude's distance above, then middle line, below the middle line, back above. Once again, we fill that in with a nice smooth curve, and we get the cosine graph. Now, what we talked about in our other video was how to change the amplitude and period. If we want to change the amplitude, we're going to go ahead and multiply the front of the trig function by a value, and that'll become the new amplitude. If we want to change the period, that's just us changing this x-axis, what we count by for each tick mark. We're going to go ahead and multiply the x value inside the trig function. Now that's not what the period becomes. That's called our period modifier. So we take our normal period of 2 pi and divide it by whatever that b value is. All right, let's go ahead and talk about how to transform by vertical transformation or vertical translation. So if we want to move our graph up and down, what we're going to do is we're going to add a positive number to move up or add a negative number to move down to the outside of the trig function. So on the outside of the trig function, we can add a number and that'll move our graph up or down, up for positive and down for negative. Now, when I do this, I like to draw a new middle line. So as I see these things, the first thing I'm going to do is draw that new middle line, and that kind of helps me do that. So let's go ahead. We'll start with labeling our graph, identifying our key features. So we'll start here. Our amplitude is 1. Our period is 2 pi. Those aren't changed at all here. We'll label the x-axis first. We have 2 pi. We have pi. We have pi over 2 and 3 pi over 2. And then I know that I'm shifting up 3. So because it says up 3 right there, I know that there's going to be a shift of up 3. All right, so because of that 3 right there. So what I'm going to do is I'm going to go ahead and I'm going to draw a new middle line up 3. The way I do, I just use like a green dashed line or something. I like to draw this dashed line. I'd encourage you to do it this way too. I'm going to go up 3, and I'm just going to draw this new dashed line. This is going to be my new kind of focus. I'm going to think of it as my x-axis like I had before. Label my y-axis, 1, 2, 3 is my new middle line, and then I have to think, what's my amplitude? My amplitude is 1, so I have to make sure I at least go 1 above and 1 below 3. So 1 above 3 is 4. I already have the 1 below. Now that I have this, the last thing to do is to plot my sine graph. It has the same shape as before. I start at my middle line. I go up to my maximum, back to my middle line, down to my minimum, back to my middle line. I'm going to go ahead and draw my nice sine. Oops. Let's go ahead and try that again and draw a nice sine graph in with those points. Now it looks a little squished just because I was trying to fit it in. But yeah, it's the same sine graph. It's just moved up 3 units. All right, now our next graph, same idea. We're going to start labeling the x-axis, and start with identifying our amplitude and period. That's 1 and 2 pi. Nothing's changed there. The only difference here is we're going to shift, and we're going to shift down 2 units. So we have 2 pi, we have pi over 2, and we have 3 pi over 2. And then we're going to shift down to units. So we have -1, -2. This is my new middle line. So I'm going to draw on that middle line, dash, 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 dash. I can go down a couple more because I know that my amplitude is 1, so I need to go down at least one more. So that's -3. And I can plot my points. Now this is where you got to be careful, and this is why we draw that middle line, because cosine doesn't start on the middle line, it starts above the middle line. So we're going to start 1 above our middle line, then go middle line, 1 below, middle line, and then 1 above the middle line. Draw in your nice smooth cosine curve. And there you go, you've shifted that graph down 2 units. Let's go ahead, let's talk about left-right shift as well. Now the left-right shift is a little bit different. With the left-right shift, this extends our graph to left and right, so we have to add kind of to our normal labeling procedures. So that's going to make things a little bit different. If your period changes, this can also mess with this as well. Now there's one extra note here, is that you have to make sure that if there is a b value, so something changing the period, something here in front of the x, you have to factor that out of the parentheses. I'll do an example of that here before we're done, just to kind of show you guys what that would look like. We're not going to have that for these first two, but that would change the period and do a left-right shift. And to make sure you do that correctly, you have to factor it out. We did that earlier with our other graphs where we factor something out at the inside of the parentheses. All right, so let's go ahead, let's label our graphs. Now, here's something that's a little tedious. People don't always love this. I always go 4 tick marks to the right and do my labeling procedures like I've done every time to start off the problem. I then add to the left or right more tick marks depending on what I need. So for both of these, our amplitudes are 1 and our periods are 2 pi. Amplitude 1 and period 2 pi. So I'm just going to label the default stuff first. So I go up 1, down -1, 2 pi, pi, pi over 2. This means it's 3 pi over 2, just like I've done every time. 2 pi, pi, pi over 2, 3 pi over 2. Every time I do that same thing, right? I label those first 4 based on whatever I found the period to be. Now, I'm going to add tick marks left and right, so that way I can shift what I need to shift. So we'll do this first one first. This first one on the left, we're shifting, and when we shift, it's opposite shift. So just like a lot of our other graphs, a positive is going to move us to the left, and a negative is going to move us to the right. So plus, let's write that up here just so we have that written down. Plus C moves us to the left, minus C moves us to the right. So I have plus pi here, so that means I need to extend my graph pi tick marks to the left. So I'll go negative pi over 2. I'm just mirroring the right side, and negative pi. And so that's pi shifted to the left. So that means that my graph is now going to start over on this unit rather than starting at 0. So otherwise, the graph is exactly the same. It's just it's starting over pi units. So sine starts at the middle line, goes up the amplitude, middle line, down the amplitude, middle line, and you can draw in your nice smooth curve. And there you go. That's the sine graph, and it's been shifted to the left pi units. Now this next graph is a little tricky because we're going to shift, but we're going to shift to the right because it says minus, and we're going to shift to the right pi over 4. All right, so I need to extend a little bit. Well, here's where the issue comes in. Pi over 4, isn't one of the tick marks on the graph. Since pi over 4 isn't one of the tick marks on the graph, what I do is I put an extra tick mark in between wherever it would be. So pi over 4 is in between right here, and I'm going to label that pi over 4. And what this means for me is that all of my dots, all of my points are going to happen in between. So I'll go in between these tick marks for all of mine. And I'm just putting a little note that pi over 4 is where I started at this in-between spot. Well, because I extended to the right, I need to go one more tick mark over. Each one of those is pi over 2. So 1, 2, 3, 4. This is 5 pi over 2. Now, I'm going to plot my points. And like I said, they're all going to be in-betweens. So we have an amplitude of 1. So cosine starts up the amplitude. So we're going to start at our little green dash mark here, in between up at 1, and then we'll go in between at 0, in between at -1, in between at 0, in between at 1. So pi over 4 was an in-between spot. I'm not bothering to label all those other in-between spots. That's a little excessive. That's a little unnecessary. But as long as I know that that in-between spot I started at pi over 4, then all my other in-between spots are equally spaced as well. Go ahead and connect up with a smooth curve, and there we have it. We are good to go. Now I got one more example for you, kind of explaining this last little piece here where we talk about factoring out our b value, and we'll talk about that here on our last example. All right, so this graph is a combination of a period change and a left-right shift. First thing I have to do is I have to factor out that period change so I get the correct left-right shift. So I'm going to rewrite this as y equals the sine, and I'm going to get some nested parentheses here. So I'll go sine of 2, and I'll go x minus, and I'm going to take that pi over 2 and divide it by 2 again. Pi over 4. Now, what I like to do after I do this is I always kind of double check. If I were to redistribute this, does it go back to what we had? 2 times x is 2x. 2 divided by 4 is 1/2. Yeah, it goes back to what I had originally. So here's what I have here. I don't have a right shift of pi over 2. I actually have a right shift of pi over 4 because I had to pull out that period change first. When you graph these and plot these, it kind of looks similar, but you got to make sure you label your stuff correctly. Your amplitude is still 1. Your period here, though, is modified by that 2 right there. So our period is 2 pi over 2, which is pi. All right, so we're going to be able to draw a graph here. Shouldn't be too hard. We draw our axes. We went up 1. We went down -1 for our amplitude. I go over 1, 2, 3, 4. That's my period, which is pi. Cut that in half, pi over 2. Cut that in half, pi over 4. Each tick marks 1/4, so 1/4, 2/4. This is 3 pi over 4. And I'm going to the right, at least one tick mark, so I'll need one more, so that's 5 pi over 4. Now, this time we have the convenient thing that our shift is pi over 4, and pi over 4 is one of our tick marks. So we'll start on that spot. We're not going to be in between this time. And since this is a sine graph, we're going to start there. We'll go up to the amplitude, then the middle line, then down the amplitude, and then the middle line again. Go ahead and fill yourself in with a nice smooth curve. And this is an accurate graph. If you did not pull out this 2 right here, you would have shifted too far over. We only want to shift over pi over 4. So be very careful. Make sure if there's a number in front of the x, you factor it out. So you divide that by 2, and that means you divide this by 2 as well. So that way you're shifting the correct amount. All right, with that information, you should have enough to be able to get started. If you have any questions, reach out to me. Otherwise, I'll see you in our next live session. Until then, I hope you have a great day.